9.6, momentum and collisions in two dimensions. These get fun. You have to deal with angles. But we've seen kind of this formula before. The motion in a plane, other than just along a single axis, has to involve x direction and y direction. So only conserved if we're going to have each component of the momentum conserved. So involving both the x direction and y direction, momentum 1 plus momentum 2 plus momentum 3 final equals momentum 1 plus momentum 2 plus momentum 3 initial, all in the x direction. And then the same will be true for the y direction. And we're just going to jump right into a problem. So peregrine falcons are amazing animals. They go like
the ones that like fly like a bullet.
Yeah, they look like a bullet. Actually,
they're the fastest animals.
200 miles an hour in their dives. Yeah, exactly.
I can go faster.
And then
In the car.
if you look at them compared to the B-2 Stealth bomber, they look pretty much like that. Yeah, it's pretty amazing. So anyway, flying at 18 meters per second right now, swoops down at a 45-degree angle from behind a pigeon. The pigeon is doomed, has no idea. So swooping down at a 45-degree angle from behind the pigeon, flying horizontally at 9 meters per second. The falcon has a mass of 0.8 kilograms, and the pigeon has a mass of 0.36 kilograms. I've actually seen a peregrine falcon, catch prey before. Yeah. Pretty amazing.
Did you get it on camera?
I was trying, and unfortunately, the falcon was very fast, but the little swallow that it was catching, the two are like, it was so fast, it's almost impossible to catch them. But I was trying. So anyway, it was a lot of fun. So anyway, here we go. What are the speed and direction of the falcon? Now holding the pigeon immediately after impact.
Sounds like we need to draw a picture.
We're going to have to draw a picture. Yep, absolutely. So from the horizontal. So the falcon at first, right? So here's the horizontal. And the falcon is flying at 18 meters per second, swoops down. So the falcon now, 45-degree angle. From behind this pigeon that's flying horizontally. So the pigeon is flying horizontally, and the falcon is going to meet up with the pigeon. Okay, so this is also going to be a 45-degree angle here.
Make it sound like they're getting dinner in a movie.
Yeah, they're just meeting up. Okay, so the falcon is flying along this, along the diagonal, right? The falcon, we should probably start writing some stuff down. The mass of the falcon is 0.80 kilograms. The mass of the pigeon, what is it? 0.36 kilograms.
So what velocity initial?
Now the velocity, yeah.
This is in horizontal, so that's going to be what, x? So VFX initial is 18 meters per second.
Okay, so it's flying at an angle though, right?
Yeah.
Okay, so we want to calculate that. So the velocity in the x direction.
Well, they're going to be, the x and y are going to be the same, right? Because it's a 45, 45, 9, right?
Yes, it will. So we have the velocity of the falcon. So we got to be very careful. It's the velocity of the falcon because F also could mean final, right?
Yeah.
Initial in the x direction.
Equals.
Okay. Now, how are we going to calculate that?
Use Pythagorean theorem.
Okay, Pythagorean theorem.
So we know he's flying.
So is the hypotenuse of that triangle
That's going to be
18?
So, yeah, that's a good question.
It'd be the adjacent.
He's flying at 18 meters per second along, like, as a diagonal? Or is he flying as a horizontal 18 meters per second?
I'd say horizontal.
What is your paper
It
say?
says he's flying at 18 and then swoops down.
down.
It has to be.
Okay, well, we know that the
I think it
pigeon,
has to be a hypotenuse because he's moving down 18 meters a second. I know it says he swoops down, but like his speed will be like, obviously it's not going to be constant, but we're kind of ignoring acceleration here, right?
well,
We kind of are. He's going to be flying.
So he's going
Which
to be
is
flying
unrealistic.
18, and so he's going to continue flying 18 as he swoops down. So that's going to change that.
He's flying at 18 meters per second along the diagonal. So we have to figure out his horizontal velocity based on that. Okay.
shouldn't
Wait.
it be equal to the
We can do
pigeons
this. We
because
can do
of the-
x delta or x root 2 equals 18. You can divide by.
Good. This is a 45, 45, 90 triangle right here.
Yeah, so it's going to be 9 root 2.
So 9 root 2 is right. So this is 9 root 2 meters per second in the x direction that he's flying.
Wouldn't we want to put that up top because doesn't that other horizontal represent the pigeon?
It doesn't matter. The top and the bottom are the same. Okay. So his horizontal velocity, the Falcon's horizontal velocity is 9 square root 2 meters per second. We can find the decimal of that, but this is exact right now, so we'll leave it like that.
Okay.
So the velocity of the Falcon initial in the y direction is what?
9 root 2.
The same because of the symmetry or the fact that it's a 45, 45, 90 meters per second. Except for the fact that this is flying down, and that is against the normal, let's put the coordinate system here, positive x, positive y.
Negative.
So this is a negative 9 root 2 meters per second. Okay. Now, we also know that the little pigeon is flying.
Horizontally.
So the velocity of the pigeon initial in the x direction was what?
9 meters per second.
9 meters per second. Okay.
Well, okay, here's the thing though. Now, when they combine, are we going to have a total system? Because he's catching it, right?
So when he catches, now we have a combined mass,
Which is going to change.
and so things are going to change, right? So now we try to put this together, and what happens?
Well, we put M, F, X.
X direction, okay.
So moment. So we're gonna have
We'll change
momentum in
colors.
the X direction. So like P1X, but we can simplify that to be M, F
So mass of the Falcon,
times the velocity of the Falcon initial
velocity of the Falcon,
X
initial x, okay?
plus
Plus,
velocity initial.
how about mass of the pigeon
Oh yeah, mass of the pigeon first.
times velocity of the pigeon initial in the x direction,
It's going to be equal to
okay?
mass
Equals
of the Falcon.
Just met M.
mass of the pigeon.
System.
Oh, well, yeah, plus
So-
To
mass
the
of
system.
I'm gonna say mass of the pigeon plus mass of the Falcon combined times velocity final.
in the X direction.
Okay, so this is where it gets tricky because it is velocity of the Falcon is what we've been using for VF, right? So we don't want to write that. We got to write something that's going to be more distinct. So velocity
After.
Last.
P plus F,
Yeah,
okay?
in the X direction.
In the X direction, final.
Okay.
Now we got to do the same for the Y direction, right? As well.
So what do we know in this formula before we do the Y direction? We will do the Y direction as well.
Except velocity.
Everything except for velocity
Fine.
of the combined thing, final, right? So we're going to need to solve for this combined velocity
So
here.
minus.
Divide by.
Simply divide by the
Oh, yeah.
combined mass, okay? So we can do that. We have velocity combined in the x direction final equals all this stuff
This is crazy amount of letters.
Yeah, all the notation here is really kind of a bummer, but it is super important.
Yeah, because as soon as we try to start doing this without it, we're gonna mess with something.
Exactly. Okay, so that is for the x direction. Now we can do the y direction. It's going to be very similar,
But
except a little bit easier because
We don't have
the
the pigeon.
pigeon is stationary. in the
pigeon's
Y
not
direction. In
stationary.
the Y direction.
Well, it doesn't have a y component, right? Okay, so what do we write?
So
Mass of the
mass of the pigeon. Let's start with pigeon.
Mass of the,
Pigeon
I'm going to use falcon first just because that's what I was doing. So mass of the falcon,
times velocity initial.
velocity of the
the
falcon,
Falcon. The Y
initial
direction,
in the y direction.
plus mass of the pigeon times the velocity of the pigeon in the Y direction.
Okay,
Initial
equals?
and 0 equals
Mass of the pigeon plus mass of the falcon times the combined
V plus P or P plus F
in the y direction
direction.
final. Okay, now you already mentioned we have no y component here, so that term is gone. And what are we looking for this time? The same thing, the combined velocity. So what are we going to do?
Divide by the other stuff.
Yes. So we will have the combined velocity in the y direction final equals, and it's just this first term divided by the combined mass.
And the mass of F divides out, right? No, it doesn't.
And it does not divide out because of it's the fact that we have two separate terms in the denominator, we cannot divide that out.
I was looking.
That's an important question though. We get that all the time. So now what can we do?
we can solve for both of them.
We can plug in our numbers and find out the components for the velocity in both the x and the y directions. So let's go ahead and do that. I don't have a whole lot of room up here. So let's go ahead and do that. I'll do the best I can though. So for the velocity in the x direction first,
So we have 0 kg times √2.
velocity final falcon IXO 9 square root 2 meters per second. Then we have mass of the pigeon. Okay, and then pigeon initial in the x direction 9 meters per second. Divide by combined mass
1.06. No, 1.16.
Okay. Anybody got an answer already for that one? I got to trust you with it.
There.
All right.
Another calculator.
$11.57.
Okay. 11.57 meters per second.
In the x direction.
Yes, that is for the x direction. So I'm going to say v sub x because this is for our final situation.
Now we gotta do the same thing. So we're gonna get a negative answer though for this, aren't we?
You would think because when they collide, they're going to probably drop, right? So it should be negative, I would think. So mass of the Falcon. Velocity of the Falcon initial in the y direction. And there's my negative sign.
I got negative 8.78.
Okay, negative 8.78 meters per second. Okay, so now we can put these things together. We have from the two birds together, we have a 11.57 in the x direction situation, and we have the negative 8.78 in the y direction, creating those two vectors, which means the sum of the vectors will give us our resulting direction of the flight. So what are we going to do?
Pythagorean theorem.
Pythagorean theorem. So this is going to be 8.78, negative 8.78, 11.57. We don't need the negative sign when we're doing the Pythagorean theorem. What do we get?
$7.54.
That's not right.
No, it can't be smaller than the two sides.
Wait, what did I do? Oh, I put the negative in. That's why.
Oh, yeah, don't use the negative.
We don't use the negative?
No.
There we go. And then 14.5.
Okay. So 14.52 meters per second. But remember that we also have to calculate the angle. We want the velocity, so we need the
Sorry.
direction as well.
Would it stay 45 degrees?
No,
Really?
no. The bird is going to hit the other bird, and they're going to drop.
It's gonna be less than 45 degrees.
Okay? So we're going to have a new angle here.
It's gonna
So
be-
we can use, since we had this one and this one, we could use tangent.
I'm gonna say it's more like 30 degrees.
No, it's going to be more than 45 because they're going, now they're going to go like this, right? Or are they going to go up?
No, so it's gonna be like, so they're going, and it's gonna be more like
Like that?
more sideways.
So tangent. Can we use tangent?
We could use anything, really.
Tangent of
Or will the momentum of the pigeon,
8.78 divided by 11.
will the momentum of the pigeon cause the other bird to level out?
That's what I said.
If it's 8.78 over 11.57.
Uh-huh. For tangent.
Degrees.
There we go.
Make sure you're using degrees.
I was gonna say I don't think it's 94.
That seems about right. Though.
0.013.
No.
Yeah, that'd be right.
0.94 seems like the correct answer in radians, right?
Wait, why'd you put over 11 if you're doing tangent? Oh, I guess.
So we should be doing opposite over adjacent. TOA is tangent. So 8.78 divided by 11.57. Tangent, 8.78 divided by 11.57, right? So tangent, theta equals 8.78
Oh,
divided by 11.57.
wait,
Yeah.
You're trying to find the angle, so you need to use
yeah,
arctangent.
I forgot.
Did you do tangent of the ratio?
Yeah.
Okay, yeah, that's not gonna work.
I don't know.
37.1.
There we go.
There we go.
37.2.
Still can save my day.
37.2 degrees. And then notice that the angle is below the horizontal. So we're going to say 37.2 degrees below the horizontal. Okay. So the peregrine was flying at 45 degrees below the horizontal to catch the pigeon. And now that it caught the pigeon, they're actually flying together at 37.2 degrees
Flying together
below
is
the
very
horizontal.
strong.
So
They're not like
Loose term.
in the
Yeah,
original
like
picture,
that.
45 degrees, but now here's the horizontal. They've actually kind of planed out a little bit. And that's because of the momentum of the pigeon carrying the peregrine forward a little
But
bit.
that wasn't a hard problem. It's just you have to keep track of it.
You got to keep track, and that's the difficult part. And if you're plugging numbers in ahead of time and figuring out things as you go, you're going to get lost. Okay. It's
Yeah, I
actually
remember.
easier to do this with the symbols instead of the numbers.